everyone. I'm Julie. I'm a data scientist at Merck. Just short survey. Who here have used LangGraph before? Okay. And has anyone heard of Merck before? Okay, nice. Okay, so it's a pleasure to welcome you all to this session. Today, I'd like to invite you to imagine this. So instead of waiting hours or days for a critical business report, what if you can just get it in 30 seconds simply by chatting with an AI agent? So in this talk, you'll see how we made this vision a reality, combining Python and LangGraph and multi-agent LLM. I promise there would be technical insights, practical takeaways, and hopefully a bit of inspiration for your own project. So let's dive in. And in many organizations, you'll find that the bottleneck isn't the analysis, it's accessing and preparing for the data. And data teams scramble through multiple dashboards, write your own SQL queries by hand, and hand off endless spreadsheets, Excel sheets, only to discover that the number that you gathered isn't really answering the questions that you're looking for. And this frustration kills innovation and multiplies stress and creates decision-making paralysis, which is not very efficient. So today we want to tackle this challenge at its core. So the reality is stark. I'm going to show you some facts. So enterprises now generate petabytes of data, and yet 30% of data professionals, their time actually goes to just preparing for the data rather than just analyzing it. And worse, 43% of decision makers report that they are not having enough confidence in experiment with their own data. And it's not an exotic failure mode, it's like everyday frustration. And teams get bogged down in this data accessing, cleaning, and preparing long before any useful insight emerge. And if we can reduce that, even by just a few hours per week, the impact would be huge. And at the same time, I want to also answer the question why large language model agents are urgent and why right now. So this year, 3/4 of organizations plan to increase their LLM investment, and 90% of Fortune 500 are already deploying Microsoft Copilot in their daily workflow. And projections put the agent market over $236 billion by 2034, and we are beyond the hype. So enterprises are moving from experiment to production-ready deployment. And the question has shifted from why AI to how do we leverage agents effectively? And our work at Merck with LangGraph sits right at the transition point. So lastly, why we choose LangGraph? So traditional large language model frameworks either oversimplify agent workflows or leave you to build your own state. And orchestration, also, you have to do it from scratch. And in LangGraph, by contrast, treat your application as a stateful graph of nodes and edges. And then you also gain built-in persistence, so agents can continue from failures. Maybe they couldn't answer the question at this moment, but if you prompt it next time, maybe it would come. And also native human-in-the-loop hooks for oversight and support for cyclic workflows that can branch or loop or coordinate multiple agents. That's all possible. So in short, it gives you low-level control without reinventing core infrastructure and making it ideal for production environments where reliability and flexibility actually matter. And we would also address these evaluation questions in the later chapters. So okay, let's pause for a quick demo video. This is our project, but I replace the real data with some fake data just to show how this how our agent behaves. So here I put some questions. So show me the monthly consumption between fuel and electricity. So this I use driving statistics. And then I just give it a prompt to see a comparison of the driving behavior and which fuel or electricity that I'm using. So now the agent behind the hood is like triggering tools that are needed, and then reasoning behind the scene, and then it gives me the visualization that I'm looking for. Take some time. All right, and this is like one scenario, but then I have also, you'll see that the agent think and then generate the SQL query necessary and executing it to visualize the plot and returning this visualization. So here I have another example where I ask similar questions. So I asked, okay, you can also give an explicit command, like how you want it to be aggregate. So aggregate per month, and then show me a group bar chart for a certain month. And then I continue interacting with it because I want to have more information from the data set that I'm interacting with. So it's like remembering the context. And then here I ask, like, what do you see in the driving pattern? And then this basically remembers the context before, and then just gives me the insight that I'm looking for. So this simple demo captures the magic. So you see the conversational querying, automatic code generation, which is probably not the news anymore if you have heard of Perplexity AI and have used the Pro feature. And also the instant visualization powered end-to-end by LangGraph. So Perplexity AI is one thing, and then here, if you want to use your own company internal data, which often involves some confidentiality, then it's better to build your own AI and have some firewall in between. So this is why we are showing you how we do it at our company. All right, so after showing you how this project actually looks like, I want to go through the context a little bit. So for our finance team, this project actually is built for our financial colleagues who are delivering sales and KPI reports. And it used to take like 4-6 hours every single day. But that meant waiting and reworking just to get the standard numbers. And our executive couldn't wait for daily batch reports. They needed accurate answers in just minutes to steer the business. And what was holding us back? So data lived in scattered systems. It's like we have to visit so many website dashboards to collect, clean, and combining everything was just slow, error-prone, and repetitive. So with my Insight agent, that's how we call it. We changed the game. So now all these fragmented sources come together in a single conversational interface, and teams simply ask their questions and get instant trustworthy answers. And what used to suck up hours now just takes seconds. And manual reporting work nearly disappears, but I can't really promise because, yeah. And this is true self-serve insight. Anyone, anywhere can ask questions and get the answers, get the numbers that they need, so the decision moving at the speed of business. And that's what we want. So just 2 slides to cover what's the rationale or philosophy behind it. So at the core of this agent, we are using the React pattern. If you're using already LangGraph, you've probably heard of this already. So it means reasoning and acting in iterative cycles. So unlike a simple chatbot, a React agent actually explicitly interleaves thought, action, and observation. So it's like interchangeably depends on what you need. So when the agent decides it needs data, it outputs an action that triggers whatever tool it needs. So here we will supply a series of tools that you think your agent needs. And here, for example, it could be a SQL generation or a query dataset tool. And then when the data returns, it triggers an observation and updates its reasoning path. And this cycle continues until the agent has enough context to generate a final human readable insight. And it gives you the best chain of thought reasoning plus real-world tool integration. And that's the goal we want. And here's a quick example again. So I ask, here on the left, so I ask compare annual sales performance for Australia and New Zealand. And the agent begins by selecting the dataset and generating the context that it needs to construct the SQL query. So here, all these bullet points underneath are the tools that we supply for this agent, and executes it. And then the agent ingest results and compute whatever financial KPI metrics it needs, and then finally create a plotly chart that we instruct it to create. So the entire dialogue remains stateful, and so follow-up questions like, okay, give me Q3 details, and it happens seamlessly and reusing the prior context and conversation. And that interactive multi-step reasoning is impossible with a vanilla large language model code. All right, so LangGraph isn't just for a proof of concept. It's our production orchestrator. It manages tool, handles error, and manages the state as well. I'll cover the state management later. So conversation context and intermediate results persist across the nodes. And when your tool call, for example, the SQL generation tool call, fails, the agent would reason about alternative queries and rather than just crashing. So this framework can actually scale horizontally, and we can actually handle over 50 concurrent users with full history checking while maintaining responsive time. So one slide to explain like this state management concept. When users chat with an agent, the conversation would twist, restarts, and rarely obeys the linear plan. Just think about how you would interact with your large language model. You can like jump between conversations, and that's where real state management matters. So first of all, it keeps the context. If you say, show me Q4 sales in Germany, and then after the next conversation you say, okay, now Austria, the agent will remember what you meant, even if you jump around. And if a process fails or you change your mind, then the agent can pick up right where things have left off, and no resets is needed. And the second thing is, it tracks all the moving parts. And by that, so every tool call, answers, and decisions flows into one organized state object under the hood. Like you see here, for example, in our project, it depends on your needs, your project needs. You might need to store different attributes. And this is how we define this. So you can do an input state, and then the intermediate state, which is not accessible. You can use it within the agent graph itself, and then we define an output state, which includes code that we use to generate the graph, the chart, and then the query data that we save. So we don't have to run another SQL query again. So okay, so nothing gets lost in the middle of the conversation. And here within LangGraph, it just makes the whole interaction more natural, and every step reads and updates the state as you go. So it lets the workflow branch and retry and ask for help when you need it. So the bottom line is this state management isn't just technical plumbing. It's why the agent needs, that's why the agent feels reliable and smart no matter how chaotic the conversation goes. To actually effectively manage your conversation flow. So that's what I promised you for the evaluation part. So as we moved this project into production and offer these services to our users in the enterprise environment, we confronted a key question. So how do we know it's working reliably every time? So agents with state inherently produce a non-deterministic reasoning path and complex tool trajectory. And traditional unit tests can't really validate the entire workflow. And we need fine-grained ways to first catch the errors early, and second, ensure the business critical correctness, and finally, monitor performance and costs in real time after we are an enterprise that tries to make money. And how do we make sure it's actually delivering the reliable result every single time? So we use 3 complementary approaches. So the first one is component level evaluation. So depending on the tool that you put it in your agent. So here in our case, we have a SQL query generation, which is a big part of it because we use it to query our data. So here we have like an approach. So ground truth comparison. We prepare a set of reference SQL queries and their expected result. And our agent's output is automatically compared for exact match at the result level. And then, of course, we care about semantic, even though the generated SQL query can look different. But as long as they are semantically different, then we accept it. And then finally, in cases where we don't have a ground truth, because you can't really exhaust or expect what your users going to ask, right? So we employ a large language model as judge, letting it assess if the agent's query and results are reasonable and satisfy the user's original question. So that's the component level. And then we have system level. So remember, we have like a sequence of tool trajectory. And for each scenario, we predict the ideal sequence of tool. And this should occur as the agent solves the user query. And we record and compare this actual series of tool trajectory and then compare to our ground truth. So this is like similar, but it happens after all the queries are after all the tools are triggered, and then you get the result, and we compare the trajectory. And this let us like catch logical missteps, missing actions, and unexpected detours. Like some tools shouldn't be triggered, but it's still there, and then we would have like good insight on that. So it helps like consistent multi-step reasoning from end to end. Oh, sorry. Yeah. And then finally, we have like deep observability with LangFuse. Anyone hear of LangFuse here? Okay, one, cool. But there are a lot of tools as such. So LangFuse is an open source platform designed to help developers observe, test, and optimize large language models applications by tracking prompt performance errors, and user interactions. But it's not just LangFuse, there are a lot of similar tools available. And they are also open source. And in this case, we have actually enterprise license, but it doesn't really stop you from using it because it's open source. And so one advantage of using LangFuse is that every prompt, every tool call, every response, every agent final decision is captured and logged as a rich trace, a session trace. And I'll show you later in a short Snapchat. And we visualize also the tool cost, model latency, and error points, and attached automated and human quality score to each session, enabling transparent and modeling this rapid troubleshooting on production. So in LangFuse, you can actually also use, okay, I'm running out of time, but you can use like extra external package like Ragas or Deep Evil to actually evaluate the traces that you capture and then turn this into a score. For example, we use a conciseness score to evaluate whether the answer, the final result is what we want. And so by evaluating at these 3 levels, we build confidence that every answer should be correct. And we have like clear overview on this dashboard that captures all the information that are important. For example, the cost per traces and who are using it per users. So every workflow is robust and improvements are guided by clear actionable data, not just guesswork. All right, so that's a short Snapchat from LangFuse showing cost and latency per model call, as well as high-level session metrics. So with these nested traces, we gain crucial advantages, which is very helpful. So in summary, robust evaluation isn't an overhead, it's your competitive edge. So by instrumenting every component and workflow with traces, you turn black box agents into observable and testable systems. And that's very important, especially in EU. And you start simple with exact match test and then layer in your LLM as judge for nuance. Then you can instrument everything, prompts, tool calls, and state transitions, and integrate tracing at deployment time rather than just as an afterthought. So with platforms like LangFuse and open source tools like I mentioned, Ragas and DeepEval, you can actually bring production-grade evaluation into your CI/CD pipelines from just day one. And finally, as data professionals, we've long chased the dream of self-serve analytics, not just for us data scientists, data analytics, but for everyone, every users. And today, LangGraph and rigorous trace-based evaluation make this dream real. So I encourage you to experiment with LangGraph. They have like pre-built commands and the whole framework where you can just like plug in your tools and start experimenting it, and then identify your own data bottlenecks and build a quick proof of concept and bake the evaluation into your pipelines from the start. And thank you so much. Now I'm happy to take any questions if there's any.
So, thanks, Julie. If you have any questions, there is a mic in the middle. So, you just come to it and ask the question. Before someone comes there, I have one question, and that's perhaps, I don't know, 2 or 3 years ago, we couldn't even imagine a thing like this. So, if you take yourself now, 2 or 3 years from now, but into the future, what do you think will be available using agents? Will it automatically perform every analysis for you, or do you have any vision for that?
I think so. This field evolves like really fast. Like when 6 months ago, when I submitted this proposal, it's like still in an experimental phase where not really a lot of YouTube tutorials are available. But now, like you see, these agent-based tools are like almost pervasive in our daily work. I mean, maybe some, like majority of the society probably not aware of it, but a lot of companies, especially you developers, are using it probably daily basis. So I think in 2-3 years, this is going to be part of your life. And maybe some more advanced agent system will come then, and then we won't think that it's such a big thing anymore. That's my vision.
Thank you. So is there any other question? I looked at Discord, there was no online question. Oh, is there? Thank you.
Yeah, hi. Thank you very much for your talk. It was very interesting. My question is regarding your data flow. And I could imagine that your LLM has then your set of tools and decides, okay, I need to write some SQL to get some data. But then how is the data put into the LLM? Was this a concern you had? Because I could imagine the error could be prone to errors when it would be transformed to a string and then run through the LLM and then in the next call and so on.
So for the data part, our company, so I believe every company has purchased a license to use their LLM behind the firewall. So even so we would wrap this data. We actually use Palantir service, and then it's some kind of big data cloud. So you have the cloud that hosts your data, and then you have the LLM that is under the firewall that consumes those data. So there's not probably privacy leaking, or is
No,
it?
I'm not talking about privacy, but that the LLM hallucinates parts of the data. So you put into the LLM the correct value, but then inside of the agent's thoughts, it gets somewhat hallucinated. You could imagine that you have, for example, pi to the 1,000th decimal point, that the agent would somewhere in the middle make an error and hallucinate some kind of data.
So for this, we have these LangFuse tools that catches those traces. So we have, like, under the hood, this evaluation per trace, where we define, oh, this is the expected answer that we are looking for. And if you deviate from this, then we would have the alert to our developers to fix this hallucination. But we can't prevent. So you probably are familiar with the large language models, and this is the intrinsic problems to hallucinate. So it's really hard to prevent this 100%. And we also rely on the domain knowledge of our users. So if it's like really deviates like crazy numbers, then they would definitely notify this. But yeah, it's still no 100% promise here.
Okay, thank you.
Yeah.
Hello, thank you for the talk. I think Jan kind of stole part of the question, but good job, Jan. So is there a way, let's say you're running this financial report, right, using this tool, and is there a way to make sure that the second time you run it, it's completely the same? So can we ensure reproducibility?
So since the LLM reasoning path is non-deterministic, but it would take into account users' question, so maybe it would trigger the tool in different order, but in the end, we hope that it would reach the same result. And this we cannot enforce, like the tool triggering the same thought all the time. But we would use our evaluation method to also adjust our prompt. If we see that if you ask the same question, but then the result is all the time different, then there must be something wrong within this reasoning path, or like the prompt, it needs to be adjusted. So system prompt or like the LM prompt, we all took us a lot of time to like fine tune it until it's satisfying. That's also one of the lessons that we learned along the way. So,
thank you.
Thank you. And we have time for the last question.
Yeah, you mentioned that you are using a reasoning model. I was curious which reasoning model exactly you are using and how is it performing in terms of speed and also cost?
So we use of course, OpenAI for all. But in our company, like we always update to the latest model. But right now we find the 4 has the best or like the fastest efficiency. So it also costs less, like other expensive models. And we also have access to Amazon Cloud. But I think we haven't actually compared different LLM models because for our purpose, for our project, it's good enough. So we didn't pursue for this comparison. But this is an interesting experiment, I think.
Yeah, really interesting. Thank you.
So thank Julie again, and so please one warm round of applause. And
thank you very much, and hope you have fun with your experiment.